Hey guys, Mrs. Ott here. I'm here to talk to you guys about our newest method of solving systems of equations, which is called substitution. So, substitution is very similar to if you know anything about sports, when you substitute one player in for another, you're putting one person in for another person. You're swapping them out interchangeably because they're probably playing the same position, right? They're the same type of player. So we're going to be doing the same thing with these equations. You're going to take one equation and plug it into the other equation to solve for one of the variables. So first I'm going to show you guys just a basic system of equations using the substitution method. So our equations here, our system would be y equals 2x plus 5 and 5x plus y equals 68. So I see that the first equation is already y equals. It's solved for y already. So I know that anytime I see a y, I can put 2x plus 5 in place of it because those two things are equal. So what I'm going to do is take that and actually substitute it into the second equation where I see that y there. Okay, this is because y is already by itself in that first equation that we can do this. So over to the side, I'm going to substitute that in, and my equation will only be x's, so that means I will be able to solve for x in the end of it. So if I rewrite that second equation, I replace the y with 2x plus 5, and then all I'm going to do from here is solve like normal. So first I need to simplify, so I'm going to get 7x plus 5 on the left side, then I'm going to subtract 5, divide by 7, and then I'll get my answer of 9. So in the end, I know my answer should be an ordered pair, x comma y. I should have two answers. So right now I have x. I also need to find the y, so I can write my ordered pair in the end. So what I'm going to have to do is take this x value and plug it into one of my equations to find the y. So it doesn't matter which equation you plug it into from the beginning. Sometimes one might be easier than the other. I personally would plug it into the top one because it's already y equals. There's not as much work involved in this one as there would be in the second one. So I'm going to rewrite this equation with 9 in it to solve for y. So I rewrote that first equation, 2x plus 5, replace the x with 9. Then from here, I'm just going to simplify, and I'm going to get 23. So then my final answer is going to be 9, comma 23. 9 from the x, 23 from the y. So that was a basic one. Let me show you one that might be a little bit harder. This is kind of a medium question, I would say, still using substitution. So you can see the setup of this one's very similar. The first equation is already x by itself. The last one was y by itself, but this one happens to be x. So we have x equals negative y plus 10, and then 4x plus 3y equals 68. So I'm going to do the same setup as I did the first time. I'm going to take that first equation, since it's already x equals just one of the variables by itself already, and I'm going to plug that information into the second equation for y. Or I'm sorry, for x, okay, because it says x equals, so anytime I see an x, I can replace it or substitute in the negative y plus 10. So again, I'm going to substitute it in. This time we're solving for y because I will only have y's in my equation. And it's going to look something like this. So I rewrote the second equation, but plugged in that negative y plus 10 in for x. Now here's the reason why it might be a little bit trickier this time. As you can see, I have 4 times all of that stuff. So what I'm going to have to do is distribute the 4 to both of those things before I get started with anything else. So I'm going to get negative 4y plus 40 when I distribute that. And then I still have plus 3y on that side and 68 on the other. Then from there, it's exactly like we did the last one. Combine the like terms, subtract over some things, divide, whatever we need to do, and we should get y equals negative 28 in the end, okay? Then from here on out, it's pretty much exactly like what we did in the last one. I'm going to take y and substitute it into one of the equations. I picked the top one just because it's going to be a little bit easier. But you could have picked the bottom one and you would still get the same answer. So now, this time we have y, we need to find x. So I plugged in negative 28 for the y in that equation. And when you simplify it down, you're going to get 28 plus 10, which is 38. So my answer, remember, it has to be an ordered pair, is 38 comma negative 28. So this one was just a little bit harder because we had to remember to distribute when we plugged in the x for that second equation. Okay, now to the harder one, probably the hardest type you will see. In both of these equations for the system, neither of them are already set up as y equals or x equals. So we have to do a little bit of work to be able to set one of those up first. So we're gonna have to rearrange one of them to be able to do the substitution. So if you look at the first equation, the 5x plus y, that one can easily be rearranged so it just says y equals. All we would have to do is move the 5x over. If I look at the second one, there's not a variable that's already kind of by itself. Okay, we have a 10x and a negative 7y. Neither of them are just 1x or 1y, so that would be a little bit more work. We could rearrange that one if we wanted to, but it would be way easier to do the first one. So I'm going to take the first one and rearrange it for y. So here's my 5x plus y equals 4. I need to subtract the 5x from each side, and I would get y by itself on the left, and then negative 5x plus 4 on the other side. If you wrote 4 minus 5x, that works too. Either way, you'll get the same answer. So then from there on out, I would plug that in. I would substitute it into my second equation. And then the rest of it is history. It's just like the last two examples. So really, the only thing that was, an extra step in this one was making sure we rearranged one of the first equations to make sure we could substitute. Everything else is exactly the same. So if you have questions, make sure you ask. Good luck on your worksheet for today.